Dear students, good time. Let's continue what we finished in the previous part of the game theory. Let's review rapidly the different forms of the game theory that happens and the different variations. The first variation was using the dominated strategy to reduce the size or minimize the size of the game to find the final solution. Okay, when we had that final solution, like the example of two politicians, the final result was 1 point, the coincidence of two strategies. Okay, so in a general term and literature of game theory, we name this point, a pure strategy. What is the meaning of this? A pure strategy is, for example, strategy 1 from the side of the player 2, strategy 2 from the side of player 1, okay, or whatever. So the other variation was the saddle point. What was the saddle point? Based on the different players and based on the different point of the views, we calculated the point minimax and maximin. If these 2 points are equal and coming from the same coincidence, we name this point as a saddle point. That is our result. It is our pure strategy, okay? The point that happens. And the other one was the third variation where there is not a saddle point, okay? This saddle point is the point that doesn't exist, okay? So that for it means that the minimax and maximin are not equal and are not located in the same location. As we reviewed before, here we need to use the mix strategy, okay? So what are these mixed strategies? It means that each of the strategies happens with one part of the probability, but for sure the sum of these probabilities is equal to 1. Okay, so to this end, before going to the next slides, let's review some exercises to understand and review a little bit the concept of the saddle point and the other items. Let's think we have a game something like this. 1, 2, 1, 2, and 3, okay? From one side, for example, here our player 1 is A, and our player 2 is B, okay? And player 2 has two different strategies. So the values that happens inside are minus 200, minus 200. Let me write it again. Minus 200, 200, minus 100, 300, 100, and 200. Sorry, my pen is not that good, so the numbers are a little bit odd. So the first step, we want to know if we have this pure strategy. It means that one of these points, or this point, or this point, or this, or this, or this one, or the other, these 6 elements, we want to know if this one is our saddle point. It means that our pure strategy or not. What we learned before, I need to form and find the minimax. The minimum between minus 200 and 200 is minus 200. The minimum between minus 100 and 300 is minus 100, okay? And the minimum between 100 and 200 is 100. So for the player 2, that is player B, what is the maximum of this column is 100, between minus 200, minus 100 and 100. Between 200, 300 and 20 and 200 is 300, sorry, is 300, okay? So now it's the time to find the minimax and maximum. Among these elements, I want to find the maximum of these elements. What is this? Maximum is this 100, okay? And among these two elements, okay, because based on that reason, we want to minimize the maximum of loss. So between 100 and 300, which one is minimum? This 100, because it's less loss in comparison with 300. So as you see, guys, these both of these numbers are mentioning this part, okay? So my recommendation for you is showing these two elements something like this. The maximum here, let me write it again. The maximum like this here, and the minimax something like this. As you see here, guys, the minimax and maximum are equal, okay, 100 and 100. If this equality happens, okay, this point is our saddle point, o punto cia, okay? So in a general form, we say that this game has a pure strategy, and the value of the game is 100, okay? It means that player A wins 100 and player 2 loses 100. But guys, in some cases, maybe happens that this saddle point doesn't exist, okay? So if this one doesn't exist, we need to apply some other items like dominated strategy and mixed strategies. Let's review them in the next slide. So let's review another type of the example to understand when we are talking about a mixed strategy, what we are talking about exactly. We just reviewed before, if there is no saddle point, it means that we don't have a pure strategy. And the other side of the pure strategy is having mixed strategy, okay? So what should we do? Let's imagine an example, something like this. Again, I have two players, player 1, that is A, and player 2, that is B. Okay, they have, each of them have two strategies, 1, 2, and the values are -2, 5, 0, and -1. Again, the first step for understanding if we have a saddle point or not is forming the minimax and maximum. Okay, how? something like this. Yeah. So the minimum between -2 and 0 is -2. The minimum between 5 and -1 is -1. The maximum between -2 and 5 is 5, and the maximum between 0 and -1 is 0. Okay? So, as you see here, guys, in this part, the maximum of the minimums, the maximin, okay? The maximin is -1, and the minimax, the minimum of these two maximums, is 0. As you see here, guys, -1 is not equal to 0. So when this happens, when these 2 points are not equal, pay attention, are not equal and are not located in the same place, it means that there is not a saddle point for this example. And another conclusion, there isn't any pure strategies. So we have a combination of strategies that we name it mixed strategy. Okay, guys? So the value of the game is between -1 and 0. Okay, but we don't know exactly what elements. The other example we saw, for example, was 100, the previous slide, because it was a pure strategy. But here, we don't see any pure strategy, and we have mixed strategies. Okay, so by the combination of the different techniques, exactly the technique of the dominated strategy, we try to solve those mixed strategies that in the next slide I will talk about them. Okay? After reviewing the last two examples, I want to tell you that in a general form, we have games with different sizes. As you remember, before I told you, in a general form, m multiplied by n shows the size of the whole game. M is the number of the strategies of the player 1, and n is the number of the strategies of player 2. So based on this combination, we have 4 different forms of our game. The first one is a game with the size of 2 multiplied by 2. Okay? The second and third one, I will separate this. The second and third one have the same form, 2. Let me clean this one. 2 multiplied by n, I will explain it, and m multiplied by 2. Okay? And finally, a game with m multiplied by n size. Why did I select these 3 groups? Because the solution and the manner of the solve of each of these exercises is totally different. For this one, we apply algebraic solution. For these two, we apply graphical solution, and for this last one, we apply linear programming solution. Okay, so what is the meaning of this M, this M, and this N? So in this case, it means that M and N are greater than or equal to 3. To this end, we separated the different types of examples. So when I say, for example, a game with a size of 2 multiplied by 5, for example, okay, as you see here, the form is solving by graphical solution. But guys, the first step to see that if I apply graphical solution is to ask this question: may I reduce the size of the game? May I decrease the size of the game? How can we decrease the size of the game? Exactly, by the dominated strategies. Okay, so if I can decrease the size of the game and in an ideal form be able, for example, to convert the size of, for example, 2 multiplied by 5 to 2 multiplied by 2, it means that there were 3 strategies that I could eliminate them. What happens here by converting 2 multiplied by 5 to 2 multiplied by 2, I reduced the solutions, okay? And in the case of 2 multiplied by 2, uh, instead of solving graphical solution, I can apply algebraic solution. For sure, algebraic solution is easier than graphical solution, as well as graphical solution is easier than linear programming. Okay, because for linear programming, it means that we have the size of the strategies of player 1 and player 2 at least 3 or more than that. Okay, so when we are talking about linear programming, what are the solutions? Easily applying a simplex manually or solver in our Excel or the other softwares that we know. Okay, so as a conclusion, in our size of the examples, I need to see if I can reduce the size of the game to someone smaller. For example, if I have a game, for example, m multiplied by n, okay, if I apply dominated strategies and change this 3 multiplied by 3 to 3 by 2, for example, it converts to something like this, m multiplied by 2. So instead of using linear programming, I can apply graphical solution. Okay, and the last item here, if there is no dominated strategy to reduce the size of the game, okay, for example, if I can't convert a game 4 multiplied by 3, okay, so I have to apply the simplex method and apply to apply the linear programming solutions. Okay, so step by step, let's review these items, but in the next slide, in a graphical form, we calculate and we review all these steps. In this slide, let's review all possible forms of a game, and let's see for each of these items what kind of solution should we apply based on what we learned in the last slide. So as you see here, guys, it starts with writing the game matrix or having the game matrix. What is the matrix? Is the payoff table, la tabla de pagos. So here we need to make a decision. Is it a pure strategy game? Pure strategy game means there is a saddle point, okay? Or I can say the minimax is equal to maximum equal to the value of the game. So learn these two items just to show them. Minimax can be shown with this form and maximin with this form. Okay, if they are equal, it means that there is a saddle point and the game has a pure strategy. So what happens here? This is our saddle point and we finish here. Okay, we finish here our example. But if the answer, okay, if the answer is no here, okay, if the answer is, let me clear it. If the answer is no, I want to check, here it was yes, yes. I want to check the size of the game. Is it a 2 multiplied by 2 game? If yes, I need to solve using analytical method. Okay, I need to solve using analytical method and then finish. Okay, analytical method is algebraic method. But if the answer is no, by using the criteria, by using the dominance strategies, we try to minimize the size of the matrix. So it means that if it's not 2 multiplied by 2, okay, I need to minimize the size of the matrix. Again, I need to ask ourselves, okay, if here it says, now after using dominated strategies, now the size is 2 by 2, 2 multiplied by 2. If the answer is yes, okay, if the answer is yes, again is solving by algebraic method and end. If the answer is no, okay, I need to ask this question from myself. If this example is 2 multiplied by n or m multiplied by 2, if the answer is yes, I need to, if the answer is yes, I need to apply graphical method, okay, graphical method to reduce the size to 2 by 2, and after that solve it by algebraic method that we see in the next slide. If the answer is no, we need to formulate it, we need to formulate this game as a linear programming and solve it, for example, by simplex or by solver, as I told you. And this here, this end gives us those mixed strategies, okay, strategies. Attention, guys. From here, okay, from here down, always our example will have a mixed strategy because our response to the first decision module was no. Okay, so for this reason we come to the next parts. Okay, so we leave this flowchart here. It's really important. Let's go to the next slide. In this slide, I want to start the graphical solution procedure. Okay, as you remember in the previous slide in that flowchart, we had one part of the flowchart. If the table is 2 multiplied by n or m multiplied by 2, the solution was graphical solution. Why? Because we wanted to use the graphical solution to reduce to 2 by 2 to have an algebraic solution. So, guys, as you see here, for example, in this table 15.6, okay, we have a table of 2 multiplied, let me correct this one. We have a table 2 multiplied by n, okay? Because we have 2 strategies for player 1 and 3 strategies for player 2. As you remember, I told you in m and n, in these classifications, m and n should be at least 3 or more. Okay, as you see here, n here has this situation. Okay, so imagine this table is a table that we have, that the example gives us, or is a result of using dominated strategies. For example, before we had a table of 3 multiplied by 3 as an example, m multiplied by n. By applying dominance strategy, we could reduce the size of the table to 2 multiplied by 3, 2 multiplied by n. So with having this form, it is possible to apply a graphical solution. So, but why graphical solution? Graphical solution is possible because for drawing, the name says graphical, okay? For drawing the different lines or vectors, we are able to draw up to 2 dimensions, okay? So we can't draw more than 2 dimensions. For this reason, we should have from one side of the strategies, one side of the players, the number 2. For this reason, if I have a table, for example, 4 multiplied by 5, I can't apply graphical solution. Okay, so as you see here, guys, in this example, you can check, but we don't have any saddle point. So when we don't have any saddle point, just review these items that we review always. But here you can check for practice. We don't have any saddle point. So it means that we don't have pure strategy. And it means that we need to apply mixed strategies. And besides, as I told you, no matter it's the first point of this table or after applying dominant strategies, but here in this table, 2 multiplied by 3 that we have, if it's not possible to find another dominant strategy to eliminate that strategy, okay, we have to apply graphical solution. If you check, there is no more strategy to eliminate. Okay, so we need to apply this graphical solution. So as you see, guys, as we had before in the part of the mixed strategy, in the form of mixed strategy, each of the strategies happen with a different probability. Okay, as an example, here I can say the strategy 1 happens with probability x1 and the strategy 2 happens with probability x2. Okay, while three strategies of player 2 happen with these three probabilities. Okay, for sure, this is x2. For sure, I know that x1 plus x2 plus x2 is equal to 1, and from the other side, I know y1 plus y2 plus y3 is equal to 1. All these probabilities should be equal to 1. Okay? So, based on the same reason that I told you, we are able to draw up to 2 dimensions. Okay? I can draw from the side that I have 2 as a size. Here is a player 1. Okay, so guys, easily to calculate these probabilities, okay, for the player 1, I can say that x2 is equal to 1 minus x1. Yes or no? So I can substitute this probability in this form instead of having x1 and x2. So in forming the lines, forming the vectors, I will have two vectors with only x1 as the probability, as the element that we are trying to find. Okay? Vice versa, if I had a table, for example, m multiplied by 2, it means that I could formulate, for example, the player 2 side as a probability of the first strategy y1 and the probability of the second strategy y2. Okay, so the y2 like here was equal to 1 minus y2. So by calculating y1, I could put that y1 in the formula of 1 minus y1 to calculate the y2 easily. So our aim is find these probabilities, the side that we have two size, okay, the size of 2, and finally find the value of the game. The next slide, I will explain more this item. Okay, to continue the previous slide, as I told you, when it's important to apply graphical solution, it's important to have one side size equal to 2. For this reason, we accept 2 multiplied by n and m multiplied by 2 to apply for a graphical solution. I repeat, why? Because if one probability is x1, the other probability is 1 minus x1, okay? Or vice versa, in case of m multiplied by 2, if one variability, if one probability is y1, the other one is y2. So, as you see, guys, as you know, here we have a mixed strategy. Why mixed strategy? Just flashback to the past. It is because we don't have a saddle point as a pure strategy. For this reason, okay, when we are saying mixed strategy, it means that, for example, in this example, a combination, okay, a combination of these two strategies, okay, whatever happens, these two strategies, okay, while player 2 selects or a strategy 1 or a strategy 2 or a strategy 3. Okay, to this end, I need to multiply these probabilities. I want to know what happens with these probabilities, the mixture of this probability 1 and 2, okay, while the uh, while the player 2 selects strategy 1. It will be x1 multiplied by 0 plus 1 minus x1 multiplied by 5. It's equal to y1. Okay. The other one is x1 x1 multiplied by minus 2 plus 1 minus x1 multiplied by 4 this time is equal to y2, and finally sorry, x1 multiplied by 2 plus 1 minus x1 multiplied by minus 3, that is equal to y3. Okay, guys, so in this slide, as we see, we have 3 lines to draw, this one, and this one, okay, based on x1. If I calculate and if I write these 3 lines, it gives us 5 minus 5 x1. The other one gives me 4 minus 6 x1, and the other one gives me minus 3 plus 5 x1. As you see here, guys, that are equal to y1 equal to y2, okay, y2 and equal to y3. As you see, guys, there are 3 different lines that we draw them. In the next slide, we'll see what happens and which is our solution. In this slide and in this table, we see sorry, what I told you in the previous slide. The important item here is, guys, when the strategies of the player 1 are mixed, it's a combination of these mixed strategies. When the player 2, sorry, selects its first strategy or second strategy or the third strategy, okay, the second or the third one, okay. As we see, there are 3 different lines to draw in our graph. So now the only item is to calculate and to draw these 3 lines to find this x1, and by finding x1 is finding the x2, that is 1 minus x1. So guys, here in this figure we have the graphical procedure for solving the game. As you see here, we just drew three lines here. This 5 minus the 5 minus 5x1, the 4 minus 6x1, and minus 3 plus 5x1. Okay, so to draw them easily in the exam, if I ask you, you need for a line you need 2 points. It's y equal to something like that. Okay, so y equal to 5 minus 5x1. One time you give 0, one time you give 1, you draw the line. It's easy. Okay, so we have drawing the lines. Okay, so these are three lines. But one important item to find this point, to find the x1, what should we do? Do you remember in the point from the point of view of the player one, we always had to find the minimums of each of the strategies, okay, and the maximum of those minimums, okay. As you remember, the table was something like this. Okay, the table was something like this: 1, 2, 1, 2, 1, 2, 3. Okay, these points were 0, 5, minus 2, 4, and 2, minus 3. Okay, guys, as you remember, we had something like this. So from the point of view of the player one, we needed to find the minimum of each of line, minus 2 and 5, 3, minus 3, minus 3. Okay, so we always try to find the minimums. Why? Because we are looking and we are solving from the point of view of the player one, or better saying, the dimension of the side of player one is equal to 2. To this end, when we are talking about minimums, okay, listen guys, about the minimums, we need to start the points that are minimum. Between minus 3 and minus 2, which one is the smaller one? Minus 3. As you see here, guys, we start from this point because it's the minimum part of our values, okay, and always we start from the left side. Okay, before continuing, just I'm telling you, as it's obvious, this continue line is the line that equal to 1. Why? Because the total of probabilities is equal to 1. Okay, we continue our line something like this. Okay, if I'm so, where is the next point? This is this point, yes or no? Okay, so how can I continue? We want to find the minimums. Okay, we want to find the minimums in comparison between this line and this line. Which one is minimum, which one is less than 1? Obviously this line. Okay, so I need to continue to this line. Okay, guys, so now I have three different points: this point that we had before, and this point. Okay, so now we found we followed the minimum form, and now what point is the maximum of these 3 points? This point, or this point, or this point. The maximum of these 3 points is this point, okay, is this point. So I know the value of x1, the value of x1 is this point that I have here. Okay, how can I find the result of the x1? Easily. Guys, always this point, maximin, or in the other example, if it's from the point of the view of y, minimax, always this point is the coincidence of two lines. What are these coincidences? The lines 4 minus 6x1 and the other line is minus 3 plus 5x1. Okay, so as you see, the other line 5 minus 5x1 doesn't have any role because it's bigger than the other than the points, and our points are excluded from this line. So easily, as you see here, I need to equalize these two lines, okay? And if I solve this equation, my x1 is equal to, let me see what is my x1. My x1 is equal to 7 divided by 11, okay? And my x2, that is 1 minus x1 is 4 divided by 11, okay? Easily I could solve and find these probabilities, okay? Now I have x1 and x2, but it means that with the probability of 7 divided by 11 of the first strategy and the probability of 4 divided by 11 of the second strategy are the strategies of this player, okay? The mixed strategies of this player. But one item is still existing. What is that item? The value of the game. Okay? The value of the game. How can I find this value of the game? Easily by substituting this x1 in either of these two lines. Either of these two lines. Why either of these two lines? It's easy because uh, because these lines are helping us to solve the solution. We check the other line 5 minus 5x1 later, we'll see what happens. If I put x1 equal to 7 divided by 11 in each of these items, the value of the game will be 2 divided by 2 divided by 11. This is the value of this game. It means that player 1 wins 2 divided by 11 units by the mixed strategy of 7 divided by 11 of strategy 1 and 4 divided by 11 of strategy 2, while player 2 loses 2 divided by 11 values of the game. Okay, guys? Okay, just to understand what is the difference between y1, y2, and y3, and y here, as we see, the y1 has a value of 0, okay? Simply, as I told you, the line of y1 that was 5 minus 5x1 didn't have any role in finding this point of x1. And as we calculated the value of the game equal to 2 divided by 11, okay, the value of the game 2 divided by 11, if I put x1 equal to 7 divided by, as we calculated before, x1 equal to 7 divided by 11, okay? So imagine we want to check if this one works for this one or not. What was that? Y1 was 5 minus 5x1. Okay, so I put y1 equal to 5 minus 5 multiplied by 7 divided by 11. If I calculate this y1, okay, if I calculate this y1, it gives me 5 minus 55, it gives me 20 divided by 11. That is another element, okay, another that is not equal to the value of the game. Okay, this is just to prove what we saw, but simply only those two lines that form that have the coincidence of that point, maximum or minimax, will help us to understand the result. It means that depends on the side of m or n, that is more than 2, okay? At least we have one point equal to, one probability equal to 0, okay? As you see here, guys, we have this 7 divided by 11 and 4 divided by 11 of the last part. And of course, the point, okay, the point that we calculated, 2 divided by 11, can be obtained by substituting x1 in each of the lines of 4 minus 6x1 and minus 3 plus 5x1. So guys, one new example here, we have now, as you see here, the general form of this, the size of this table is m multiplied by 2, okay? Why? Because we have 4 strategies in the side of player 1. So what is our first step? Our first step is check if there is any saddle point. Why? Because presence of saddle point means that there is a pure strategy, and that is our result. Okay, so let's calculate the minimum of each of the strategy for player 1 and the maximum of each of the strategies for player 2. Okay, so here between 1 and minus 5, which one is minimum? Minus 5, and the other one is minus 4. The other one is minus 2, between minus 2 and 3. Between 0 and minus 5 is minus 5. The other side, the maximum between 1, minus 4, minus 2, and 0 is 1. And the maximum between minus 5, 4, 3, and minus 5 is 4. Okay? As you see here, in this side, the maximum is minus 2, and in this side, the minimax is 1. Okay? As you see here, because these two elements are not equal, it means that the game hasn't a saddle point. The game hasn't a pure strategy. Okay, so I need to search the mixed strategy. But in mixed strategy, here, as you see, guys, we have a game at this moment 4 multiplied by 2. But is it possible to, using dominated strategies, reduce the size of the game? If it's possible, better. Okay? How can I find it? Comparing the strategies of player 1 with each other and comparing the strategies of player 2 with each other. It means that 1, 2, 3, 4 with each other and 1, 2 with each other. As you see here, guys, the strategy 1 of the first player and the strategy 4 of the player, 1 is greater than or equal to 0. Yes. -5 is greater than or equal to -5. Yes. So strategy 1 dominates strategy 4. I can eliminate this strategy. Okay. So what it remains for me is a table now with 3 strategies. Okay. For the player 1 and 2 strategies for player 2. What are these elements? Let's write with the other color. 1 minus 5 minus 4, 4 minus 2 and 3. Okay. Do I have any other dominate strategy? I don't see any more. Okay. So in this side, now I have the variabilities y1, y2, x1, x2, and x3. Three different probabilities. Sorry, variability. No, the probabilities of each of these items. Exactly like the previous part, I can write this one as 1 minus 1 minus y1. Yes or no? So if I put these elements, okay, these variabilities, these mixed, sorry, I repeat, variability is right, the probabilities, it means that the mixed strategies of player 2 while player 1 selects the pure strategy or 1 or 2 or 3. Okay, so it means that is y1 minus 5 multiplied by 1 minus y1 is x1 is minus 4y1 plus 4 multiplied by 1 minus y1, that is x2, okay, minus 2y1 plus 3 multiplied by 1 minus y1, that is equal to x3. Okay, guys? So now again, I have 3 lines to draw in my system. I will do it in the next slide because here I don't have any space. So guys, as you see from the previous slide, we have these 3 vectors. x1 is equal to 6, y1 minus 5. x2 is equal to minus 8, y1 plus 4. And y3 is equal to minus 5, y1 plus 3. Okay, so if I draw these 3 lines, this line, this line, and this line easily, as I told you, for drawing a line, I need 2 points of that. Okay, I draw these 3 lines. But this part, this side, it is important for us that we are looking from the point of view of the player 2. Okay, we are going to find the minimax point. Okay, so between the maximum points, I need to find the minimum ones. So as you remember in the table, in the previous table, we had 2 points, 1 and 4. What is this point? Obviously, this is that point 4. Okay, and but we are going toward the maximum point. I will go downward. I will have these 2 points. Between these 2 points, this line and this line, which one is the maximum one? This line that I showed you with blue. Okay, this point again. Between this red line and this black line, which one is bigger one? This red line. So I showed you with blue. As you see here, guys, I have 4 points. This point, this point, this point, and this point. Okay, so among these 4 maximum points, which one is the minimum among the others? This point. Okay, this is my point that I name it as minimax. Minimum of the maximums. Okay, what are the lines of these two? Easily, again, I need to give these 2 lines. Okay, what are these 2 lines that we have? Are line 3 and 1. It means that this point doesn't have any relation with line 2. So I need to put these 2 elements equal to each other. Okay, equal to each other, and I will find the element of y1 equal to 8 divided by 11. So based on this element, if I put y2 equal to 1 minus y1, it will give us 3 divided by 11. So simply, if I put whatever these 2 items in our lines that form this point, that was line 1 or 3, in each of them, if I put, I will obtain the value of the game, equal to -7 divided by 11. Okay, it means that player 2 wins 7 divided by 11, while player 1 loses 7 divided by 11. Okay, so this is the value of the game. For sure, if it's something like this, my x2 that doesn't have any role in forming this point will be equal to 0. Okay, guys? Than